So, a few days ago, we got to sit here, or I guess it was yesterday, kind of seems very long after the end of the week. I got to sit and listen to Clint introduce Evan, and I loved his introduction. And he went into the history and why he respects the individual. And so I'm sitting here thinking, well, how am I going to introduce Rasmus? So I know Rasmus, so I've been kicking around at conferences and traveling around the planet. I've been in a car with him as he drives along Greek roads and a bad highway system at fast speeds. I've watched him in Australia stand on stages, and, well, we'll just leave it at that. And I've seen him do so many things over the years, and we know him from the MySQL world, of course, for that standard compliance limit that was added to MySQL. But really, I don't believe Rasmus actually needs much of an introduction. Rasmus is the father of PHP, which is an impressive thing. We're talking about something which runs a good, considerable number of the largest websites on the planet. And despite the amount of promotion other languages have gotten, budgets, marketing people, and etc., PHP as a language has stood on its own as something, and it's probably one of the more both dynamic and creative elements to what we see in open source. So, no further, let me introduce to you Rasmus.
On the slides, there they are. All right. Good morning. This is very, very early for me. I struggled to get into work by about 11:30, so I've never seen the sun this early. My slides are online here. If you find anything interesting at all in this presentation, you want to grab some of the code snippets I'm going to show you. They'll be online there. I'll show this URL at the end as well. talks.php.net. You can navigate your way to it as well. So, I'm not really a keynote type of guy. I'm a backroom geek. I write back-end code for web applications. I do architecture work. I do security work. I really shouldn't be speaking in front of people. We have the guys like Guy Kawasaki, who's a really, really good keynoter. Next to him, I feel kind of silly being up here. But I'm here because I'm old, mostly. I started this stuff. I started web stuff back in 1993 when I saw that, the Mosaic web browser. I was actually working for a Brazilian software company, writing some really cool stuff, but it was not web-related at all. And the first time I saw the Mosaic browser, I phoned up the owners of the company in Brazil and said, look guys, we have to change the entire company right now, do nothing but internet, because this thing is going to take over the world. And they didn't agree, so I quit. And I moved back to Canada and started doing some web consulting. And back then, web pages looked like this. Well, the code behind them, HTML behind them looked like this. So you had home pages, and everyone had a stupid counter at the bottom of the pages. Like I said, this many visits, the little graphical thing. And it was usually written in Perl, and so a little CGI bin counter like that. And it really wasn't very impressive, and those counters were meaningless to anybody other than the person who put it on there. I was hired to write dynamic web pages back then, to take whatever back-end databases, whatever information companies and universities had that they wanted to put online. They hired me to help them build that. And I ended up writing the same code over and over again. I wrote a lot of CGI programs in C. And after a while, I got really tired of writing the same C code over and over again. So I collected all my C code that I'd written over the past 6 months or so and stuck it into a library. And then I came up with a very, very simple template parser that would parse my HTML template and make calls into my C code. This is basically PHP version 1, circa 1994. Now, it doesn't look a whole lot like PHP looks today. You can sort of figure out what it's doing by looking at it. There's a getty and B to get the user agent, for example. Check to see if it's Mozilla. And then you say, hey, you're using Netscape. There's an SQL query in there. So in the very, very first version, had SQL queries. Back then, I was using a database called Mini SQL by a guy named David Hughes out of Australia. And so we had a little bit of SQL queries. We had a little bit of logic, so if less, You'll see there are no curly braces, there's no semicolons. Very, very simple templating language. Now, since back then it was basically just me using this, I could make changes on a whim. Every day I would change the language drastically. And it didn't take very long. So by 1995, mid-1995 or so, PHP looked like this. This isn't that far from what PHP looks like today, actually. Here you can easily see there's a few differences. You'll notice there are no curly braces. That while loop looks like a syntax error because it's while with a semicolon after it. But I was really, really bad at writing parsers. I still am really bad at writing parsers. So it's much easier to me to have a token that says while, end while, if, end if, right? Things like that. So I actually knew which structure I was closing. So I didn't have curly braces at all. Now, 10 years later, well, more than that, 12 years later, I suppose, but as of 2005, that same code looks more like that. I'm not so sure that this is worth 10 years of development, but computer science folks are happy with this because it's now all object-oriented, because that's cool. We have things like protected properties, we have abstract methods, we have all the stuff that this computer science teacher really told me you should be using. I don't care about this crap at all, actually. I care about building a tool that solves a problem. I hate programming with a passion. I wrote PHP to avoid programming. I want to get to solve the problem as fast as I can. And the way I wrote PHP, I sort of built it on what I knew and what I thought other people would already know and make the learning curve really, really shallow. Kids coming out of universities today, this is what they know. They know object-oriented programming. This is what's familiar to them. I've had folks that had to explain what procedural programming was. I showed them a function call, like, well, where's the class? Where does this come from? I mean, I don't understand this procedural call. It's just sitting there all by itself doing, I don't understand. And to me, that was a bit of an eye-opener. And that's why PHP has changed and evolved a bit to be more like modern object-oriented languages, is that because people expect that way of programming. So that's what we're doing on the PHP world. Now, PHP is open source, obviously. I've been doing this open source stuff for many, many years. People always ask me, so why do you give away your code? Why do you actually do this stuff? And I think there are 4 different types of open source developers in the world. I'm very much of the first type on that slide, purely self-interest. I needed a tool that solved the problem. My interest is not that much in the tool, my interest is in solving problems. And the various folks that hired me back then, the big one being the University of Toronto, hired me to build this big dial-up system for them that was web-driven. They didn't care how I did it, they just wanted the solution. So if I wanted to open source my tools along the way, it's perfectly fine with them. So a lot of PHP was actually written for the University of Toronto. So for me, it was purely self-interest. I open sourced it because other people asked me, hey, how'd you do that? And I said, well, this is how I did it. Here's my tool. They grabbed it. They started sending me patches. The University of Toronto thought it was brilliant because I was writing code at an amazing rate. Even in my sleep, I was fixing bugs. Every morning, I would get to my mailbox and say, hey, there's like 3 or 4 bug fixes for bugs I didn't even know I had coming from all over the world. And I thought it was a great system. Why not get together with other people from around the world who have the same problems, and we would all get together, work on a tool that fixed this common problem. And each one of us looked like we were brilliant in our own little world because we were building this tool so fast and using the scale of having people all around the world working on it. So I thought it was just a really good model for developing software, of developing this tool that I needed. Other people have other ideas. I mean, other people contribute self-expression. There are people who actually like programming. I don't understand why they like programming, but people who like programming, they want to sort of express themselves. A painter paints and shows his paintings to other people, and a musician wants to perform in front of people because that's how they express themselves. Programmers, they want to show their code to other people. Right? said, hey, I'm a great programmer, look at this code, look at this intricate way I solved this one problem, look at this cool algorithm I came up with. And that's how they express themselves. And I think that's great, because without the real programmers, PHP wouldn't be here today. I'm not a real programmer. I throw together things until it works, then I move on. The real programmers will sit there and say, yeah, it works, but you're leaking memory everywhere. Perhaps you should fix that. Like, I'll just restart Apache every 10 requests. That's fixed. So, I'm not that much of a details guy. I get it working, I come up with some ideas, other people really make this stuff useful. Hormones. There's this very cool hormone called oxytocin. It's basically nature's trust hormone. And you have a lot of kids, a lot of geeks, who really don't interact very well with other people. But these kids still need to interact with other people. And when you do interact with other people, you have this hormone that flows, this oxytocin hormone, that makes you feel good. It's the same hormone that gets secreted during childbirth, during orgasms, both for men and women. And when you interact with other people, it comes out as well. You see lots of geeks playing World of Warcraft, for example. I wouldn't necessarily call them geeks, but lots of introverted kids playing World of Warcraft. And it's one of these things, these big interactive online games, they do actually interact with other people. And then that gets their oxytocin flowing. Some of the other kids that aren't that much into games, they will actually join an open source project and contribute to it and talk to other people that way. And that's their way of interacting with their peers, as opposed to going to a bar or going out and playing baseball with their friends or something. They sit in front of the computer and they do open source stuff. And then there's a few weirdos who do things just to improve the world. Say, I'm going to work on open source because I'm going to make the world a better place. Now, I think a lot of open source does make the world a better place, which is a cool side effect. But I would really be lying if I said that I set out to improve the world with PHP. I did. I needed a tool. Other people found it useful. Great. So, how does this relate to anything you care about? In running an open source project, I think this statement holds very, very true. You cannot run a decent open source project if you make it all about you. It really has to be all about the people who contribute to the open source project. You have to think about how do people feel about themselves when they are involved in this project. You have to give up some ownership. You have to give them the idea that it's their project and that we're all in it together. And that was one of the hardest things for me initially, because it was my thing. PHP was my baby. Giving up control and basically taking a step back and being a contributor to it like anybody else, without having any special powers over anybody. If somebody disagreed with me, if there were 3 of us and 2 guys said, no, we have to do it this way, and I completely disagreed, it doesn't matter. Just because I started it doesn't mean I have a bigger say in it. And that was a little bit hard in the beginning. But then again, I'm a really lazy guy. And if other people feel really strongly about a thing, I'm way too lazy to fight them. All right, so I think the same statement holds true in a world that you guys might care a little bit about. All these sites out there, I think, show the same characteristic. In order to build a decent modern web application, you really have to think about what the users feel about themselves when they interact with your site. And I think this is what Web 2.0 means, at least this is my meaning of it, that a site that harnesses the users and basically every single interaction the user makes with your website improves your site. It's not like back in the old days in the Web 1.0 world where a website was like a newspaper. Right? You would put up some information, people would come every day and look at your site, read it and go away, they'd come back the next day. If you hadn't put new stuff up there, there'd be nothing for them to see and they would eventually go away. And that's a lot of work because you have to provide new and interesting content every single day. That just doesn't scale at all, right? But these sites are successful because once you build the framework for the site, you're done, right? The users provide all the interesting information. what would YouTube be without user-contributed videos? Really, really boring, right? There'd be nothing there. MySpace, and some of the others, like Netflix, there's obviously content there without user contributions, but it's much more interesting that you can see what other people in your area, which videos they're interested in. The ratings, reviews, things like that. Amazon has the same thing. One of the things that's interesting about Amazon is that you have all these reviews, you have all these people commenting on the product, and people who bought this also bought that. And that's things that's directly harnessed from every click. On Flickr, for example, Flickr without user-contributed photos would suck. And some of the interesting things Flickr does as well is they will aggregate information. So they'll look at all the photos and see, well, there's a lot of people using the Canon cameras. And there's actually a page on Flickr where you can see what's the most popular camera these days, or which cameras are on the upswing, which ones are on the downswing, just based on which cameras they pull out the EXIF information on the pictures. So you can get a lot of even indirect aggregate information out of your users as well. So, in order to build a successful modern website, I think you have to keep that exact same 4 groups of people in mind. The same type of people, the same types of motivations that motivate people to join and work on open source projects, I think motivate people to join and interact with websites. There are people who upload their photos to Flickr purely out of self-interest. They need some place to store their photos online so their brother in Spain can go and look at the photo of their kid, right? There are photographers who upload their photos because it's like their gallery, their online gallery of their work. If you browse around Flickr, you'll see a whole lot of hormones as well. And finally, there's a few that contribute to sites to improve the world. I don't know if Flickr is the case here, but Wikipedia might be a good example of people actually believing that they can improve the world by helping out on a site like Wikipedia. So, that was a little bit on the motivation behind building a site and what types of things you need to attract users. Now, if you attract lots of users that are passionate, their hormones are flowing, they're interacting with your website, if your website doesn't work, it doesn't really matter what you came up with or how great your idea was or how passionate your users are. If your site falls apart, you're done. And we've had a few examples over the years of things that really, really caught people's attention, but then the site didn't work and they went away and someone else came along and ate their lunch. So, here's where you get into some techie stuff. In order for your website to work, you have to figure out how to scale the thing, how fast it is, how fast it needs to be, how many servers you need. You have to worry about latency. So I did a talk on Tuesday where I showed a little bit of benchmarking on a site. And I had a small server at home. I stuck Drupal on it and wanted to see how fast is Drupal actually. Drupal is a PHP-based content management system. And when I first installed it, I ran that first benchmark. HTTP load minus parallel 5 fetches 100. So it says do 5 parallel concurrent connections and do 100 requests. How fast can you do it? And they came back and told me that it could do 3.9 fetches per second at milliseconds to first response. It's what's called the latency. So that's the delay between the request gets sent to the server and the first byte comes back. And they told me 1.2 seconds. So about 4 requests per second at 1.2 seconds latency. That's pretty damn slow. So I looked at that and went, well, it's a slow server. It's a server from about 5 years ago, but still. It shouldn't be that slow. Why is it so slow? So the very first tool I always use when I want to see why something is slow is callgrind. Callgrind is this really cool profile that works inside another tool called Valgrind. And Valgrind is an x86 chip emulator. You can emulate the entire chip in there. You can run code on this emulator. And the callgrind on top of it, you can get very nice graphs of what's happening. So when I did this on the Drupal site, I got a graph that didn't look like that. It looked like this. And you see sort of an overview of the actual, of all the steps that this application took. So this is at the C level. So we start off with main at the top with 100%, and then each box is the amount of CPU time spent at this stage when anything at this stage calls. And I've configured it only to show me things that take at least 2% of my CPU time. So you go down through, you're inside Apache invoke handler, Apache internal redirect, send parse PHP. So here was the handoff from Apache into PHP. And then you can see that we spend 94% of the time executing the script and about 4.5% of our time shutting down after each request. So then you can follow down one of the branches here, and you can have a look at what's actually happening. You can see it does some includes, it does some other things, compiles our file, parses the file. There's not a whole lot to be seen from this particular script. You can see that if you put an opcode cache in to get rid of the compile stage, you remove about 25% of your CPU time. So other than that, there wasn't a big major thing that stood out there. But I always like to get an initial view of where things are happening in my code when I'm doing any sort of optimization. There's no point starting to optimize without knowing where to focus your efforts. And you have to run the profiler first. So this told me, other than putting an opcode cache in, there wasn't a whole lot to do because everything is at the PHP level. It includes and stuff, but no major hurdle otherwise. So the next thing I did was I added Xdebug to my little PHP server and turned on the profiler. And when I hit the page a bunch of times, it spat out another output file that I loaded into this tool called kcachebranch. And this picture, then I got a picture that looked like this. And here you have spaghetti code, otherwise known as Drupal. And you start off at main at the top here, and you see some of the main things that we have. The Drupal bootstrap, you have menu handling, and you have the theming. And the theming is 52% of your time. You can walk into the theming here, and you can see from the overview here, you really need a big screen. This 1024 by 760 doesn't really do it justice. But you have all this spaghetti code here, and all these things ends up doing a DB query. And it turns out, on accelerated, there's a couple of acceleration options inside Drupal, but on accelerated, a single page view in my particular Drupal install needed 47 SQL queries. 46 selects and one update. That's a lot of queries to do on one request. None of the big sites out there. I mean, if somebody came along at Yahoo and said, oh, we're going to launch a new property, we need 47 SQL queries per request, all the architecture review boards would say, you guys are nuts, no way in hell are we ever going to let you launch this, right? You need to get things down to a couple of queries and a lot of caching. You don't want to do 47 queries per request. So, after looking at those two profiling, it wasn't that hard. I installed an opcode cache, and then I just tweaked the acceleration options inside Drupal itself. And after doing those two things, without changing any code, I got it to that second one there. So 81 requests per second at 50 millisecond latency. Much, much better. You can get it to be much faster as well. You can really dive into any one of these squares on the profiling chart there. But each one you do is going to be harder and harder to get more performance out of it. So this was about maybe 25 minutes of work for me to go from 4 requests per second to 81 requests per second. And if you spend a day on your website doing this instead of 30 minutes, I guarantee you can speed it up. Unless your developers were brilliant to start out with, I guarantee you can double the speed of your website just by looking at the profile and output from callbranch, both from callbranch and from Xdebug. You'll find things that you didn't realize. Hey, I didn't know this little tiny useless feature was taking up 40% of my CPU time. Let's just shut that off. We don't even use this thing. There's always something like that. All right. So the second thing that will make your site fall down is security problems. So you have a great idea, you have lots of passionate users, you profiled it, you made your site go fast, then someone comes along and hacks you. Someone comes along and puts something in their MySpace profile, and everybody who used their MySpace profile then gets infected with the same bit of JavaScript that then basically tears your site apart. You get lots of news stories written out about how insecure your stuff is, and investors start calling you and complaining, and it's really not a good thing. Lots of bad things happen if you have security problems in your site. And everyone has security problems in their sites these days. It's just a matter of people being interested enough in your site to go find them. So some of the common places where people make mistakes. The 404 page. This is a very, very typical place to have a cross-site scripting problem. You type in the URL with some JavaScript in it. That file, that location doesn't exist on the server, so you put up a nice friendly page that says, sorry, I couldn't find proof. And you show the exact URL, including the JavaScript in there. That then is a cross-site scripting hole, because you cannot run user-supplied JavaScript in your domain. If you do that, many bad things can happen. I'll explain that a bit. Your search page, search results page is another place where you show the search query, you forget to escape it. PHP self, request URI, obviously user-supplied data like get, post, cookie, any stuff in the server array can be exploitable. And there's various problems and a lot of other technologies we use as well. Older versions of Apache have security problems. IE has all sorts of interesting things that we don't really expect. For example, if your website does not send a char set, if you haven't configured either Apache or PHP to actually specify that this stuff is in ISO 8859-1 or it's in UTF-8, then IE will guess. And IE will guess by looking at the actual output. And if it sees something in UTF-7, it will switch into UTF-7 mode. So if you had inject JavaScript in UTF-7, IE will happily execute it because it sees, hey, this looks like UTF-7. I'm going to switch into UTF-7 mode. And what's bad there is that all your filters, you might actually have tried to filter out tags and JavaScripts and things. But if you're filtering it in UTF-8, then you're not going to catch this stuff because in UTF-7, all the stuff looks very, very innocent. And all your UTF-7 characters is going to slide right through all your filters. So make sure you send the char set. And the various other problems in IE with the Adobe Reader plugin, the Flash plugin, how they interact with IE have had nasty security problems over the last couple of months. So basically right now, the web is completely broken. You can't really secure a website because even if you make your site completely secure, if the user of your site is running an older version of IE, an older version of the Adobe plugin, the PDF Reader plugin, an older version of the Flash plugin, they are vulnerable. So any sort of personal data that they have put on your site, hackers can get simply by attacking them, by tricking them into clicking on a link. Even if your site is completely secure, it doesn't mean the data that users are stored on your site is secure, because the hackers can go through insecure software on their machines, which isn't really news, but it's really annoying because you feel a sense of frustration that you can't fix it. You can't secure your client's data with this. But it is what it is. We only have one web, so we have to make do with what we have. And at the very least, you need to do stuff so that your site isn't the one that's providing the hole for the hackers. So, what can actually happen if you do have a cross-site scripting hole on your site? And trust me, 9 out of 10 of you have cross-site scripting holes on your website. Some of the things that can happen. Basically, if you have a cross-site scripting hole, I don't know if you know Grease Monkey, but Grease Monkey is a way of doing very interesting things. Basically taking a web page and hacking it up and making it do something that it wasn't designed to do. If you have a cross-site scripting hole, the hackers can basically Grease Monkey your site and get victims to run the Grease Monkey site of the site. I mean, it's Grease Monkey without Grease Monkey. For example, did you guys know that I was the super duper sponsor of this conference? Never mind diamond sponsors or gold sponsors, I'm the super duper sponsor of this website. And it's actually a PHP conference, as you can see by the logo right there as well. So yes, the conference site is very much cross-site scriptable. Somebody forgot to filter some user input. If you wrote this website, talk to me, I'll show you where you went wrong. Another one. IBM has a very nice page up on cross-site scripting, which is of course cross-site scriptable. So, and it's just, I mean, I picked on these two particular sites just because I find them funny. 80% of all websites out there have holes. Some of them not that serious, some of them very, very serious, but most of them have holes. written this automated scanner that finds this stuff. I was going to publicize, I was going to open source it, put it out there, but man, it finds problems in every site, including Yahoo, where I work. And I basically wrote it for Yahoo, so they're not that keen on me putting out a tool that will find holes in Yahoo itself. And it finds holes everywhere. Banks, insurance companies, governments, the CIA, everywhere. So, I don't know. I'm not sure I want to be the guy who breaks the web by releasing this tool. I said that at another conference, and someone suggested, didn't you already break the web? And there may be some truth to that. So some of the other things that can happen. So these are sort of very innocent things. I ran an alert box on that site. I changed the output of this site a little bit. And I mean, just changing the way a site looks is not that big a deal. But some of the things you can do, if you can run JavaScript on the victim's browser in somebody else's domain, one interesting thing you can do, you can put up this hidden div with a bunch of different sites. So login.yahoo, mail.google, Slashdot, Amazon, Bank of America, Bank One. And then by looking at the DOM in the browser, you can go through and you can see what color is the link. And simply by looking at the color of the link, programmatically of course, you know whether or not this user is a Bank of America customer or Bank One. If they've recently been to Bank of America, you know. Then you can do a script source to that, and based on the error message that comes back, you can't really get the content, but based on the error message, you can figure out if they've logged in, if they're currently logged into Bank of America. If they visited Bank of America recently, they're currently logged into Bank of America, hey, great, then you have all the login credentials, should be in the cookie jar, you can just start sending JavaScript requests, like transfer money or whatever. I mean, all this kind of stuff, if you're logged in to a site that has any sort of personal information about you, and you're browsing the web out there in another tab in the same browser instance, you're screwed. You have no way of knowing whether or not one of these sites that you're browsing is running JavaScript that's doing something nasty behind the scenes. You should never ever click on a link. Which, I mean, that sort of defeats the purpose of the web, but I use two browsers. I have one browser for anything personal, and then a completely different browser. Safari, I use for personal stuff, and Firefox for browsing the Wild West out there. I never, ever use the same browser instance to do personal stuff and non-personal stuff, because it's insane. JavaScript Trojans. There's a guy named Jeremiah Grossman in San Diego, has a security company called White Hat Security. And he's written this very cool Trojan. So if you can inject JavaScript into a user's browser simply by tricking them into clicking on a link, which is very easy, then he can basically take over the entire browser. So he puts an invisible iframe, and then he puts whatever site you're at in the middle of the iframe. And as you're clicking around, as long as you're not escaping out of the iframe by going and picking one of your bookmarks and typing in a new URL, as long as you keep clicking inside your window, then he has full control of your browser. Even if you go to a different site, by clicking on a link inside that window, he has full control of your browser. He knows everything about you. He sees every keystroke that you type, for example. He can issue commands here, so he can say, well, I would like to do a JavaScript request to your router. So he knows your internal IP, so he can make a JavaScript request to .1. Most people who are browsing from home, .1 is their wireless gateway. Most people don't change the default password in the wireless gateways. So he goes in and he changes the DMZ setting in the wireless gateway. He takes the current machine, makes it the DMZ host. The DMZ is the demilitarized zone. Basically, he takes that machine and moves it outside the firewall by reconfiguring the wireless router. Then he can use traditional hacks, port scans, everything to actually try to get into your machine. A lot of people say, well, my Windows box is behind my firewall. I'm not vulnerable at all to all this stuff. No, I don't need to lock down my Windows box that badly. Very simply, via JavaScript, he can move your Windows machine outside the firewall. Then he can attack various insecure ports, your file shares, whatever. So if you're sharing your network shares inside your firewall, they're not inside your firewall anymore. This same stuff happens with corporate firewalls. If you have your users, if you have your employees browsing the internal network and the external world at the same time, that user becomes the conduit for the hacker, because cross-site scripting with JavaScript trojans, the hacker doesn't need direct access to the machine he wants to attack. He simply needs a JavaScript trojan installed on the middleman that has access to both, and at that point he can then do the equivalent of a port scan. He can do a script, he can find your IP, then he can do a script source .1, .2, .3, .4, .5. He can find web servers behind the firewall. Once he finds a web server behind the firewall, he can start poking that web server and doing interesting things to it. So corporate firewalls really don't matter anymore, because you don't need to go directly at it. We have all these idiot users who are perfect gateways around the firewall. All right. So, what are we doing about this? In the PHP world, there isn't that much we can do, but one of the things we need to do, and one of the things we have done, is we've introduced the filter extension in PHP 5.2. It's available for 5.1 as well via PECL. I wrote it initially about 5 years ago, or 4.5 years ago for Yahoo, and there we filter everything by default. That means that all user input is filtered, and if the developer needs raw access to the data, so if a request comes in, last name has a single quote in it, the default filter will change that single quote to its entity. So ampersand number 039 semicolon is what actually shows up when you try to get at the $_get. So if you access it directly via PHP, you're going to get the entity version of that string in that case. That can be very annoying for people, but it's very, very useful. And it's really useful for auditing this code as well, because there is an access function to get the raw. So you have to call filter input, in the example on the slide, input post. So from the post get data, give you the message variable, and give you that through the unsafe raw filter. And that's a lot of typing. It's a little bit annoying to people, but it's really, really nice from an audit perspective. I can grab through hundreds of thousands of lines of code and pick out the 5 places where they're allowing raw data to come in. I think of it as a data firewall, right? In a network firewall, you would never open up all the ports and then just lock down 2 or 3, right? That's how we build web applications these days. We let everything in, and then we say, oh, I should probably filter here, here, and here, right? It's a really bad idea. So the filter extension flips that idea on its head and says, we're going to filter everything. If you need raw access to data, you have to specifically poke holes in that data firewall in only the places where you need to poke a hole. Otherwise, the data is filtered through a very, very strict filter that pulls out all the things that you feel could be harmful to your site. There are many different types of filters you can install. You can build your own filter as well, where you decide which characters you want to let through by default. But a decent one tends to be the special charge filter that does the same as if you're familiar with PHP, the XML special charge call. So this is available in PHP 5.2. You can go have a look at this slide online. There are various ways of defining your input strategy. So here's that thing that says filter var array, where you can specify all your input arguments, and you can specify the filter for each of your arguments, and put that at the top of your script, and that completely defines what you're going to allow through your filter. And then you don't have to think about it anymore. All right, 8 minutes left. APIs is the final thing I want to talk about when you're building these modern applications. So you have passionate users who've made the site go fast, you've thought a little bit about security. You can't make it completely secure, but it's at least a little bit more secure than the next guy, which is usually all you need. As long as you're not the slowest guy being chased by a tiger, right? You're okay. So, slide there. I find the APIs really, really cool. So here's the 2-liner. It's basically a 1-liner. Right? If that URL, if my slide was wider, I could put that URL variable directly into that call. This is a 1-liner that goes and grabs the Atom feed from Flickr, which is the recently uploaded photos to Flickr. find the Flickr API really cool because they expose things that are very, very useful that you really want to use. You saw I updated the slide about a different set of photos each time I do it, right? So these are the photos that were just uploaded. It's sometimes a little bit dicey showing that. We've got nice cute rabbits today. So I find these APIs really cool because they really make you want to use the service because it's so easy. In a single line, I've written an application that's actually kind of interesting, right? I can sit here and draw this slide a lot of times. We'd always see something interesting. And there's one line of code. That's all I needed to add to my application somewhere to put these photos up. Another example I really like, and this is a lot of code. Most of this code is me trying to figure out the math behind taking a latitude, longitude point on the map and then getting a 2 by 2 kilometer box around the center of that point. So that's most of what that math is. Then once I've passed that coordinates, that set of coordinates to Flickr, and I tell it, give me all the photos taken in this square, this geographic square over the last 4 days, it comes back and of course tells me that no photos were found. There were some last night, but I guess it's more than 4 days out. We'll pick up other people. And what's interesting to me about this is that I didn't put in MySQL conference. I didn't put in Santa Clara, right? What I put in was simply a geographical square on the globe that says, show me any pictures that was taken in this geographical location in the last 4 days, and what we get are pictures from this conference, right? And which may not seem that cool to you, but I find it really, really cool that without actually putting in the tag and saying, I know there's a MySQL conference, can you find me some pictures from this MySQL conference? I'm just saying, show me whatever the heck is happening in this spot on the globe right now. And it's showing us Martin Handy and Guy Kawasaki or something, sure thing, right? I find that really cool. Once more people and once cameras can automatically geocode digital pictures, I think this is going to be amazing. We have a beach volleyball court on the Yahoo campus, and I've constructed my little query, I've got my rectangle exactly to be the outline of this beach volleyball court at Yahoo. And you reload this thing, and every couple of days there are new photos that have been very meticulously geocoded to say that we're on this beach volleyball court. And I find that really, really cool. That you can have this window into a certain spot on the globe. Whenever a picture is taken on that spot, you see it. I think that's cool. So APIs are things like that that really drive passion and drives people to use your site. So be like Flickr, create cool APIs. And if you're also using other people's APIs, you can add a lot of value, a lot of cool things to your application. YouTube, which we'll hear about next, has done that a lot, right? You see YouTube videos embedded in other sites everywhere. It's one of the reasons everyone uses YouTube. Who wants to build their own video upload service? If you want to be able to embed some videos into your site, well, just tell your users, go upload it to YouTube, and here's the little snippet you need to put into your page. Now you have an embedded video in your page. Same with Flickr. Why bother building another minor or mini Flickr sites? Tell people to use Flickr. If that's not your core business, let the people who are good at it do it. All right. I'm almost out of time. But some final thoughts. Participation gimmicks really tend not to work. If you have to pay your users to use your site, it might seem like a good idea at the beginning, but it doesn't really scale very well, and it's probably not the type of users you really want. You want users who are passionate about the site and will use it on their own without you having to trick them. Get their hormones flowing. Try only to solve one problem. You see way too many sites that try to be portals. We have enough portals. Well, I work for Yahoo, so how many portals do we really need? Try to build a very clean and intuitive API, well, API and UI as well. And finally, make it work. Make sure it's fast. Make sure it's somewhat secure. And things will be good if you do these things. If you don't, it will fall over, and somebody else will go through these steps and build a site that works. Again, the slides for this
this talk and talks about PHP.net. Thank you very much.